Now, we often hear new terms such as visualized networks and the SDN networks. What are the protocols used by these new visualized networks? Today, I'd like to share with you the basic principles and the configuration methods of EVPN and VXLAN. There are many L2 technologies. You may have encountered VPLS, MPLS L2 VPN, EVI before. When these traditional L2 protocols are applied to large networks, such as the current cloud network, they cannot meet all the needs of customers. At this time, a new network technology based on EVPN to control VXLAN forwarding was produced. The emergence of new technology will definitely solve some problems that cannot be solved by traditional protocols. Let's first understand what VXLAN is. VXLAN is an overlay network built on a physical IP network. Its first advantage is that it uses UDP to encapsulate the inner Ethernet packet. The encapsulation header is 50 bytes in total, including VNI of 24 bits, which is the VXLAN ID, which can support more than 16 million virtual networks at most. Solves the problem of insufficient VLAN resource. The second advantage is that it can cross the traditional physical three-layer network and open up a large layer 2 network above the three-layer network. The third advantage is that VXLAN can realize traffic load by using different UDP source ports for different data streams. After we have a basic understanding of VXLAN, let's understand the implementation principle of VXLAN. First of all, there is a virtual switch instance, namely VSI, on the switch, as a virtual VXLAN forwarding switch to guide the forwarding of VXLAN packets. Here it is noted that the VSI and the VXLAN should be one-to-one correspondence. Then build a VXLAN tunnel, and the devices at both ends of the tunnel are called VTAP device. After the tunnel is established, associate the VXLAN with the VXLAN tunnel. Note that one VXLAN can be associated with multiple VXLAN tunnel. Finally, the AC port is used to identify the VXLAN to which the received packet belongs, so that the MAC and ARP addresses of the packet can be learned into the VSI corresponding to the VXLAN, and then VXLAN encapsulation and forwarding are performed. The various advantages of VXLAN have been mentioned above, but the traditional VXLAN still has some shortcomings. The first is that tunnel establishment and the VXLAN matching need to be completed manually. If there is a lot of business, the configuration is relatively cumbersome. The second is that the traditional VXLAN protocol only completes the encapsulation and the forwarding of packets, but the learning of table entries is entirely completed by flooding behavior, which will lead to ARP and other broadcast packets forwarding into the entire overlay network, occupying extra bandwidth. Since VXLAN has such shortcomings, how can we solve these problems? Next, the perfect control plane (EVPN) is on the stage. The packet forwarding in VXLAN network can be divided into two planes. One is the control plane, and the other is the forwarding plane. The control plane mainly learns MAC, ARP, and other entries to guide the forwarding path of VXLAN packets, while the forwarding plan is to complete the encapsulation and decapsulation of the original packet to VXLAN. EVPN inherits the advantages of the VXLAN data forwarding plan and optimizes the control plan. By using MPBGP to advertise routing information, it can automatically establish VXLAN tunnels, which greatly reduce the manual configuration of VXLAN. At the same time, it synchronizes entries information through routing, solved the problem of broadcast traffic. Let's learn about the working mechanism of EVPN. The common networking of EVPN is a two-layer architecture of span and leaf, and the IBGP is usually used for interconnection. EVPN can advertise VXLAN information through routing, and the VTAPs make judgments based on the received routing information. If there are identical VXLANs, VXLAN tunnels will be automatically established and associated. At the same time, EVPN uses MPBGP routing entries to complete the distribution and recovery of MAC and host routing addresses, and learns entries between devices to guide VXLAN traffic forwarding. After having a basic understanding of VXLAN and the EVPN, let's take a look at how to configure it. Since manual VXLAN configuration is relatively simple and has fewer applications, we will focus on the configuration process of VXLAN network based on EVPN. In the networking shown in the figure, two S6800 devices are used as VTAP devices and are interconnected with the middle S12504X device at layer 3. The virtual machines on the same network segment are located under two S6800s, and the addresses are 10.1.1.1 and 10.1.1.2 respectively. Now, a large two-layer VXLAN network based on EVPN control is built between the two switch devices to realize the intercommunication between virtual machines. First step, establish BGP VPN neighbor. To transmit messages through MPBGP, you need to establish a corresponding neighbor. MPBGP defines a new EVPN address cluster under the L2VPN address family, activates the EVPN neighbor under this address family. Then VXLAN tunnel can be established automatically, and the MAC and host routing can be synchronized through routing. The configuration here is similar to our traditional BGP configuration. In the case of ensuring the interoperability of the underlay network, specify the loopback addresses of the two-leaf device to establish neighbors under BGP. The special note here is that the undo policy VPN target command needs to be configured under the EVPN address cluster to ensure the correct reflection of the route. After completing the basic BGP configuration of the three devices, you can use display BGP peer L2VPN EVPN on the devices to check whether the neighbors are established normally. The second step is to enable L2VPN. VXLAN technology also belongs to L2VPN technology. By default, the L2VPN function is turned off. If it is not turned on, VSI-related configuration cannot be performed. So you need to turn on the L2VPN function of the device. Step 3. Close the VXLAN tunnel self-learning. Because EVPN itself can synchronize table entries through MPBGP routing messages, there is no need to use VXLAN tunnel forwarding for learning. The VXLAN Terminal MAC Learning Disable and the VXLAN Terminal ARP Learning Disable commands can be used to disable the VXLAN protocol self-learning function. Step 4. Create and plan VSI and the VXLAN. Configure VSI encapsulation mode. The VSI and the VXLAN on the device need to be planned by the user. The user can configure multiple VXLAN and the VSI instances on the device. Here we configure a VSI VPN10 switch instance on two VTAP devices and configure VXLAN10 to bind to it. After there is a corresponding VSI, the VTAP carries the RD and the RT configured under the corresponding VSI of the VXLAN when publishing the root of the VXLAN, and the remote VTAP can compare whether to learn, thereby achieving the purpose of routing learning control. Here RD and RT are configured in automatic mode, and the device automatically fills in RD and RT values. Of course, it can also be configured manually. After the creation of VSI and VXLAN on both VTAP devices, you can use the display VXLAN terminal command to check whether the terminal is normally established. Step 5. Associate AC port with VSI. In order to ensure that packets can enter the corresponding VSI, the AC port needs to be associated. Configure the service instance first, then configure the matching rules, and finally associate with the VSI. Through this configuration, packets with VLAN 10 tags on the outer layer can enter VSI VPN10 for forwarding. After completing the above configuration, the VXLAN large layer 2 network has been opened up. You can use display L2 VPN MAC address to check whether the MACs on both sides are learning normally. At this point, you can see that one MAC is learned locally, and the other MAC is learned through EVPN to the Tunnel 0 tunnel port. At this time, the two virtual machines can communicate with each other. Well, through the above explanation, do you have a very clear idea about the configuration process of the EVPN-based VXLAN network? Let's review the key content of the entire configuration process. Number 1. VSI and VXLAN on different VTAP should be one-to-one and configured correctly. Number 2. EVPN is actually BGP. When configuring, pay attention to establishing a residence under the EVPN address cluster. On span, you need to configure undue policy VPN target. Number 3. When configuring the AC interface, pay attention to the correct mapping relationship. Otherwise, it may not be able to match the original packet to the VXLAN. The application of EVPN or VXLAN in the data center is very common, and the standardized configuration can ensure the stable operation of the network. I hope everyone can have a clearer understanding of the configuration of EVPN and VXLAN through the study of this episode.